Basic Calculus, Lesson 6.2, Definite Integrals. So, we gave you a quick rundown of distance, area, volume using finite sums. And now we're going to, of course, expand it and be official about it. So, we talked about getting those little divisions smaller and smaller. It sounds like we're going to take a limit. And, of course, we are. Although we will not need our limit powers as we once did. So we're adding up those things. These are called terms. And it's a sequence when we add it up. I think I might be screwing that up, but who cares? So let's add them up. The LRAM, MRAM, and RRAM stuff we did was the way it's done. And this is called a Riemann sum. And you can structure it any way you want. Make a big fat one, make one LRAM, do this, do that. Whatever. And I'm going to gloss on this, be warned. So we have a definition of the definite intervals, a limit of Riemann sums. So we have something called the smallest interval. That's what the P stands for. I forgot what it stands for. And now I got it here. It's not the partition. It's the oh goodness gracious, the norm. That's funny. It can get smaller and smaller. We create a limit. And what we're saying here is that there is going to be an integral. And if there is going to be an integral, we tie it all together with, if it's continuous, we have a limit. Now the fun part is we don't even use this like we did with differential calculus. We just go straight to how do we rewrite it. Here's the integral sign. It means the integral from a to b, which just means the sum of the areas under the curve, f of x, so the ck becomes an x, dx. That's it. A to b is the region we're working in. F of x is the function. D of x is the variable it's being referred to. So here's one. Looks nasty. It's not. Just says rewrite it. We got a interval working off of. This all just means 3 f of x, pardon me, 3x squared minus 2x plus 5 dx. And that's all we're doing. So this is the area under the curve again, and we can define it as the definite integral. We're going to tie it together with derivatives eventually. But here it is, the area under the curve, if it's integrable over a closed interval, it's right there. It says, by the way, it's got to be non-negative. What that means is that it has to be above, so it can be, anything up here from A to B. And then we'll get the area. But if it's below the curve, the integral will be negative. So don't worry about it. We're just doing integrals today. We'll get into the whole area thing eventually. But before we start talking about that, we say, well, all right, evaluate the integral. But now the integral is just an area. So you say, oh, hey, I know that. That's a circle from here to here with a radius of 2. So it's half a circle. So the integral above the x-axis will be 1/2 pi 2 squared, also known as 2 pi. Now I showed this last lesson how to do it with the calculator. I'll show it again. We can put it in here. I always have trouble memory what I'm typing when I put it in. 4 minus x squared, enter. And let's set up the window from -3 to 3, and from -1 to 3. So there it is. And I say I want the area under there, so we do this integral thing. It's kind of cool. It maps it out. It tells us the answer is 2 pi. 6.283, 2 pi. Other way to do it with the calculator, math. This one's nice because it gives us the whole integral from -2. Oops, go to. Sorry, I got to zoom around in it first. To 2 of square root 4 minus x squared dx. And it tells us after a while, it really grinds us out. I'm sure it's using a numerical thing. 2 pi. So that's under math number 9. Definitely want to know where that is. It's called NINT. And if you're doing it with a NINT calculator, which is an older one, you put the function, you put x, you put the a, and then you put the b. That's really about it. I mean, this is what I talked about. The derivative will be negative if you're below. I can show you that if you want. Let's go with the second insert, negative, enter, change the window so we get to see it. From -3, enter, to 1, enter. Graph. I screwed something up. Window. Yeah, that's not right. -3 to 1. See if it graphs me this time. It does. So this is the one below the x-axis. Should get -6.28 when we do it. Second calc 7, -2, 2. We get area below the axis, so it tells us it's negative. More on that later. So if we do it for sine, and I just did one, I'm not going to do it again. Sine from 0 to 2 pi. Looking at this, well, we're going to get 0. And I strongly suggest you try it yourself. So these two areas are going to cancel out. So the integral from 0 to 2 pi sine of x dx will equal 0. We could also have functions that are discontinuous. So we can do one of these. -1, 2. This is x, so it's going to look like this. 1, -1. And we're looking at the area here and here. This area is 2 times 1. This area is -1 times 1. Combined, we get 1. And how do we find the integral of a constant function? Well, that's just b minus a times the function, so it's 4. So the integral from a to b of k dx is just going to be b minus a times k, as we just showed. I think that's about it. Yes, it is. Not too bad stuff. Get on it now and you'll be happy later. Happy mathing.